In this example, we are going to be simplifying the following so that we find a final answer with no negative exponents. So we're reviewing some properties of exponents to simplify our answers. So in this first part, we have negative 2 times 8. We're going to treat numbers like they're numbers. Multiplication means multiplication. Negative 2 times 8 has always been negative 16. But now with properties of exponents, multiplication, multiplying bases means adding powers. So when you have x's in here that their bases are multiplied, you're going to add those two powers. So I'm going to do negative 12 plus 9, which is going to give me x to the negative 3. This is not my final answer though, because my answer should not have any negative exponents. So I'm going to leave that number just as it is, but if I have a negative power, I'm going to move that to the denominator. So negative 16 over x to the 3. Notice we do not move negative numbers to the denominator. Negative 2 times 8 has always been negative 16, not 1 over negative 16. That would be a decimal or a fraction. So we're going to leave numbers like numbers, but if it's a negative exponent, it belongs in the denominator. So moving over to letter C over here, I'm going to do some division. First, I'm going to divide numbers. 10 divided by 4. I can plug that into my calculator if I need to and hit math, enter, enter to reduce it. 10 over 4 does reduce to be 5 over 2. Next, I'm dividing bases. So instead of using regular division, division of bases means subtracting powers. So I'm going to do 5 minus 11. I'm going to subtract whatever power is in the denominator. And then same thing with y. I'm going to do y, and I have negative 6 in the top. I'm going to subtract the power from the bottom, so I'm going to subtract 1. So for the x term, I'm going to get 5 minus 11. It's going to give me x to the negative 6. For the y term, I have negative 6 minus the 1 power from the denominator is negative 7, which tells me both x to the 6th and y to the 7th belong in the denominator since they were negative. So I have 5 over 2, x to the 6th, y to the 7th. Division means subtract whatever power is in the denominator. So multiplication meant adding, division meant subtracting. Our next property is when we have a power raised to a power. Well, first of all, I'm going to treat numbers like they're numbers. I'm going to grab my calculator and raise 3 to the negative 2. 3 to the negative 2 is 0.1 repeating in my calculator. I'm going to hit math, enter, enter, and I'm going to get 1 over 9. Well, hey, that makes sense because I have a negative power. It goes in the denominator, so I have 1 over 3 squared, or 1 over 9, just like my calculator said. And next, I have some powers to a power. So multiplying bases meant adding powers, dividing bases meant subtracting powers, and now a power to a power means multiplication. So I'm going to do 2 times negative 2 for that C, and then I have D to the negative 4 times negative 2. A power to a power means multiplication, so it's going to be C to the 2 times negative 2 is negative 4, and D to the negative 2 and times negative 4 is going to give me a positive 8. So that tells me I have D to the 8 in the top and C to the 4th in the bottom. Any negative exponent is going to go into the bottom. I could leave it like that, or we could just write D to the 8th over 9C to the 4th. So raise the number to the power 3 to the negative 2 using your calculator. And then for the other ones, a power to a power means multiplication. Last little piece of review here is when you have a square root. The square root is a 1/2 power. So you could write it like this, x to the 20th, and then a square root is 1/2. Or the other way of saying it is it's power over root. So I have the 20th power over the second root. They both give you the same thing. Half of 20, or 20 divided by 2, is going to give you x to the 10th. Power over roots, and I'm going to give you an extra example of that since I know roots are hard. Nobody really likes fractions. Let's do the third root of x to the 12th. You can always write power over roots. The power is 12, the root is 3. This would be x to the 4th. Power over root, so 20 over 2 or 12 over 3, a couple examples of writing power over root. And just remember the square root means the second root, so you're dividing by 2 when you do your power over root.